Yes. Hello students. Once again welcome to chemistry classes from Spark Academy. Today our topic is chemical bonding. We are going to discuss chemical bonding today. So now for this chemical bonding weightage, what expect in this session? So in chemical bonding, weightage is for Jee Mains one question, and for this Eamcet 1 to 2 questions. So we expect in this session questions from first one. First one is Poisson's rule. Poisson's rule. Second one is hybridization. And the third one is VSEPR theory related question. Means what? Their shape of the molecules, shape, bond parameters. Clear? Next, Emotic, molecular orbital theory related questions. Molecular orbital theory. Last one, hydrogen bonding. Yes. So expect in this session from this, okay, Poisson's rule, hybridization, VSEPR theory, in that shapes, bond parameters, bond angle, bond length, dipole moment, resonance structures, etc. So Emotic, molecular orbital theory. In molecular orbital theory, questions are bond order, magnetic behavior. In magnetic behavior, para, dia. Now hydrogen bonding in that strong bond or intermolecular hydrogen bonding or intramolecular hydrogen bonding related questions. Now let's see our topic, chemical bonding. Yes. What is chemical bonding? Here, see, these two atoms, they held together. So what is the attraction force, okay, present in these constituent atoms that held them together? Okay, the electrostatic attraction force which is hold together these constituent atoms is called chemical bonding. Clear? So chemical bonding definition. Chemical bonding definition, it is, see, two different atoms but they are together. So what is the force made them held together? That force of attraction only called chemical bonding. Download our app for great discounts on our courses and offerings also there. JEE, Eamcet, NEET, daily preparation, subject-wise content, study material. Free handwritten notes available from our side, free study materials, previous year questions, free mock tests. Now come to our topic, yes, chemical bonding. This chemical bonding, in that chemical bonding, for explanation, so Courcelle-Lewis, they were approached and they given Courcelle-Lewis theory. Courcelle-Lewis theory explained octet rule. What is octet rule? In periodic table, except zero group elements, the remaining elements, they don't have octet electronic configuration. So by losing, gaining, combining atoms, they get octet electronic configuration. That octet electronic configuration is called outermost orbit contain 8 electrons. That one explained by Lewis from by their approach. Now come to the formation of hydrogen, chlorine and carbon dioxide molecules. For formation of hydrogen, as hydrogen atom, one more hydrogen atom is required. They combine, form H2 molecule. Same way in the case of the S, which one? Chlorine. In chlorine, Cl plus Cl. Both are atomic formed Cl2 molecule. Same way, carbon dioxide, carbon and oxygen. Given carbon dioxide S. So atoms are less stable compared with their molecules. Okay, when they combine and they gives what? Energy. They releases energy along with formation of the molecule like H2, Cl2, CO2, carbon dioxide. Now, theories. What are the theories explaining chemical bonding? So, in that first theory is called electrovalent theory. Yes, electrovalent theory. This theory was proposed by Lewis. So, it is called Lewis approach. Next theory is Valency shell electron pair repulsion theory. So, Valency shell electron pair repulsion theory explained organic molecules, covalent molecules, geometry, bond angle, bond order. Next, VBT or orbital hybridization theory. Valence bond theory also called orbital hybridization theory. So orbital hybridization theory explaining how many hybrid orbitals present in molecule, which is the central atom. That atom's atomic orbitals undergoes hybridization. Next, Emotic molecular orbital theory. So molecular orbital theory explaining bond order and magnetic property of the molecules. So bond order is what? Between the atoms. Is it what? Bond order 1 or 2 or 3? What is the magnetic moment of the molecules? Either that is para or dia. Now octet rule. Just now we learned octet rule. Octet rule is called 8 electrons rule. So in every atom, yes, outermost orbital electrons, if they contain 8 electrons, then we say it follows 8 electron octet rule. So octet rule in that, which are very important. So valence electrons are very important. So valence electrons crucible role in the case of the octet rule. Now this valence electrons shown by Lewis in the form of the Lewis dot structures. Now come to the first one, lithium. Lithium according to Lewis dot structure is shown, okay, valence electron 1, beryllium 2, boron 3, carbon 4 electrons. After carbon, nitrogen, how many? 5 electrons. Oxygen 6 electrons. Fluorine 7 electrons. What about neon? It is 8 electrons. Means neon 0 group element followed 8 electrons. Octet rule. Same way like lithium, sodium is 1. Like beryllium, magnesium is 2. Like boron, aluminium is 3. Like carbon, silicon is 4 electron having. Like nitrogen, phosphorus, how many? 5 electrons. Like oxygen, sulfur is 6 electrons. Like fluorine, chlorine is 7 electrons. Like neon, argon has how many electrons? 8 electrons, yes. So Lewis shown valence electrons. So valence electrons very important in the case of the bond formation. So valence electrons, okay, shown in the form of the structures. Who? Lewis. So these are called Lewis dot structures. Next, what are the types of chemical bonds present? Chemical bonds, there are two types. What is the first one? First one is primary bond. What is the second one? Secondary bond. So how we can differentiate the primary bond and secondary bond? Primary bond or secondary bond? Yes. Primary bond or secondary bond, how we can differentiate? Yes, students please, okay, who are in online, okay, please share your doubts. Yes. Yes, see. Yes, please share your doubts. SC, S. Okay, types of bonds. How many two types of bond depends on what? Okay. In which direct and complete rearrangement of electrons. So we considering here valency electrons. Valency electrons complete rearrangement taken place. Such bond is called here primary bond. If valency electrons, okay, incomplete, no complete means no rearrangement there. Valence electron. Such bond is called secondary bond. So here credit goes to valence electrons. As now primary bond. Primary bond how many types? Ionic bond, covalent bond, metallic bond. So secondary bond, hydrogen bond, van der Waals bond, dipole-dipole bond. So primary bond is what? Rearrangement of valence electrons bond. Here no rearrangement of valence electrons, even formed bond, that is hydrogen bond, van der Waals bond, what? Dipole-dipole bond. Next, so now let us see how ionic bond will form. What are the other names of the ionic bond? Ionic bond also called electrovalent bond, polar bond. What is polarity? Polarity means ionic nature. Now what is ionic bond? Complete transfer of electron from one atom to other atom. So otherwise we say when transfer of electrons from one atom to other atom possible, so one element is losing electron, one more is gaining electron. So what is the result? Ions. So charged particles are called ions. So here metallic element has here positive charge because loss of electron. So gain of electron is, okay, symbol is negative charge. So they are called charged particles. Charged particles are called ions. Ions, they have electrostatic force of attraction. Due to the electrostatic force of attraction, they comes close and forms bond between them. Such bond is known as ionic bond. Yes, now ionic bond, electrovalent bond, polar bond. Now we take the example magnesium. What is the magnesium atomic number? Magnesium atomic number is 12. So losing 2 electrons, it becomes octet rule, means losing 10 electrons. So valence electrons 8, now it is stable. But which magnesium lost 2 electrons, one is, okay, that is transfers to the fluorine. One more transfers to the one more fluorine. Then what is the result? Result is Mg2 plus. What about fluorine? F minus, because gained, it also gained F minus. Now magnesium fluorines, they have the charges. They are called now charged particles. Now these charged particles have force of attraction. Electrostatic force of attraction is there. So due to electrostatic force of attraction, they formed as what? Here. Okay, they are formed here. Yes. What they are formed here? Okay, they are formed here ionic bond. Yes. So result is ionic bond. What is the resulting compound? Mg. Yes. What about EF2? Magnesium chloride. Now one more example. Magnesium chloride. MgCl2. MgCl2 also example for ionic compound. Magnesium. Last two electrons. So due to octet electronic configuration, due to get the octet electronic configuration. Now electrons transferred which were lost by the magnesium. One is goes to chlorine, one more that chlorine. The result is what? MgCl2. So by this way, magnesium chloride will form. This is explaining the formation of the magnesium chloride. Next, so after completing the electrovalency bond, so electrovalency bond nothing but ionic bond. So what is electrovalency? So NaCl is example for ionic compound. NgCl2 AlF3. In that, number of electrons transferred in the formation of the ionic bond. Now what is the electrovalency of the sodium? +1. Yes. What is the electrovalency of the chlorine? -1. What is the electrovalency of the magnesium? +2. Chlorine? -1. How many chlorines there? 2. Every chlorine has -1. Now aluminium, yes, +3 electrovalency. Fluorine, -1, -1, -1 because 3 fluorines there. Clear? So electrovalency nothing but okay, number of electrons transferred in the formation of the ionic bond. Okay, so ionic compounds they contain valency. Such valency is called electrovalency. Next, what are the favorable conditions for the formation of the cation? So cation is essential for formation of the ionic bond. So what are the favorable conditions to form the cation? Low IP. So ionization potential is low, then that atom will form cation easily. For example, first group elements. What are the first group elements? First group lithium, sodium, potassium, rubidium, cesium. These are first group elements. In that, which one has low ionization potential? Lithium to cesium atomic size increases. Then what about ionization potential? Decreases. Then cesium has here what? Low IP. So it is readily forms cation. Cesium. Low charge on the cation. Yes. So cation which has the low charge, it readily forms ionic compound. Example, Na plus, Al3 plus, Mg2 plus. So which cation has here low charge? Sodium. So sodium readily forms. Compare with aluminium, magnesium easily what? Ionic compound. Ionic compound, yes. Next, large atomic size. So large atomic size forms easily cation. So large atomic size one. Large atomic size, yes. We take the example now. Large atomic size. So which one has the large atomic size? Yes, we take here potassium rubidium. Yes. Potassium rubidium, which element has, metallic element has the large atomic size? Rubidium. Then rubidium readily forms cation. Inert gas, yes. So inert gas configuration is there. So such element forms easily cation. Inert gas configuration. For example, we take which one? Zinc. Zn plus 2. Yes. Next we take Ca plus 2. What is the atomic number of calcium? 20. Losing 2 electrons? 18. Zinc 30 losing 2 electron? 28. Which one has the inert gas configuration? So So calcium has inert gas configuration. It readily forms cation. It is easily forms ionic compound. Yes. So what are the favorable conditions? Low charge, low IP, low charge on cation, large atomic size, inert gas configuration. These all are favorable conditions for cation formation, leads to ionic bond. Next, what are the factors? Now factors which are favorable for the formation of the anion. What is the charge of the anion? Negative. Yes. So negative charged particles are called anions. How cation is essential for formation of the ionic compound? Same, anion also essential. Now what are the favorable conditions for formation of the anion? Small atomic size. So small atomic size easily forms anion. Small atomic size. Small atomic size. Fluorine, chlorine, bromine, iodine. Yes. Which one has the small atomic size? Fluorine. So fluorine readily forms anion. Fluorine, fluoride. High EA and high EN. High EA and high EN. Yes. So EA means electron affinity. EN means electronegativity. Electronegativity. Now chlorine, bromine, iodine elements there. So which element has high electron affinity and electron gain enthalpy? Chlorine. So chlorine readily forms anion. Yes. Low charge on anion. So what is the charge of this? What is the charge of the anions we have to take? Anion charges. So what about carbon? Carbon after nitrogen. Okay, next oxygen, nitrogen, oxygen, fluorine. So what is the charge of nitrogen? 3 minus. What about oxygen? 2 minus. Fluorine 1 minus. Yes. So which one readily forms anion? Fluorine. Yes. So these are the what? Favorable conditions, factors for formation of the anion. So formation of the anion, favorable conditions is yes. Next, as link description, yes. Spark store, long-term courses 2022 to 23. Crash courses 2022 to 23, mock test, previous year solutions, full length test, study material also available. See admissions open, join now short term crash courses, long term short term coachings, timings, regular coaching also available, classroom coaching, online classes also. At our 2 branches, Narayanguda and Mehdipatnam. Call 91-333-80172, 8977-525-461 for JEE, Eamcet, NEET admissions. Admissions open, join now, online coachings, live courses. Okay, for online coaching. So online coaching was available. Buy and enroll your number. Our live sessions by this way takes place. So some examples: daily on demand live sessions, maths, physics, chemistry. So see principles they given here: general organic chemistry, electrochemistry, biology, Eamcet revision. Assignments there, everyday assignments, every weekend test. So immediately, instantaneously you will get the test details. So grade in that appear student, average time taken, average score, average grade also you will get. So our methodology, what are our methodologies? Basic concepts, see. So basic concepts are very important for any subject. Shortcut methods like in our chemistry, hybridization. all model questions, exercise questions, previous questions, chapter-wise test, weekend test, grand test, and test analysis also available. So after this, we see some topic-related questions. Yes. See the first question, first example. Electron configuration. Yes, we have here given electronic configuration 1s2, 2s2, 2p6, 3s1. So that is A. And B given what? 1s2, 2s2, 2p6, 3s2, 3p4. Yes, the possible compound that can be formed between A and B. Now we check A, 1s2, 2s2, 2p6, 3s1. Now, how many electrons required to get stable octet electronic configuration? Because last orbit 1 means 7 impossible. So this element losing one electron. Losing one electron, it becomes what? Stable. Yes. Then it becomes what? A plus. Means positive. Now 1s2, 2s2, 2p6, 3s2, 3p4. Yes. So how many electrons required to get stable for this one? Already 3s2, 6 there electrons. Again how many required? 2. So it gains which one? B. Yes. 2 minus. Means what about A valency here? 1. So B valency 2. Crisscross method. A to B. Yes. So what is the molecule? R. Possible C. So here compound is possible A to B. A to B is there? Yes. This is the answer. Yes. Because electronic configuration and regarding valency, you will get A to B compound or molecule. Yes. Next question. Yes. What is our next question? Yes. Next question is variable valency is the property of. What is variable valency? What is valency? Valency nothing but outermost orbit electrons. So outermost orbit electrons are called valence electrons. And combining capacity of the atom is called valency. Alkyl metals, they are showing as valency 1. Alkaline earth metals, they are showing valency how much? They are showing valency 2. What about inert gases? Inert gases, they contain 8 electrons in outermost orbit. Then their valency electrons are 8, but their valency, yes, combining capacity is 0. Then, so which elements they are showing the variable valency? Transition elements. So what are transition elements? D block elements, they are called transition elements. So D block elements, they are showing more than one, okay, valency. Such valency is called variable valency. So D block elements, transition elements, they are showing more than one valency. So the such valency is called variable valency. What is the answer? Answer is 2. Transition metals, they have property of variable valence. So this variable valence is nothing but, okay, more than one valence. Next question. Yes. 2 atoms there here, X and Y. Yes. The 2 atoms X and Y have 5 and 7 valence electrons. So X has how many electrons here? X has 5. So how many required? 3 required. Yes. So what about Y? Yes. Y has 7 valency electrons. How many required? 1. See. So here they given valence electrons. Valence electrons nothing but outermost orbit electrons. So according to Coastal-Lewis theory, so valency electrons only responsible for formation of the bond. Now we got here X has 5, means how many required to get stable? 3. So Y has 7, how many electrons required to get stable? 1. Yes. So y1 x3, then you take the crisscross, then y3 as x s. Then can I write by this way x3y, then x okay 1 y3 as possible, yes. So this compound is there, yes, xy3, yes. What is the correct answer? This one, xy3. So xy3 is present, yes, clear. So answer is xy3. Clear, students? Any students there in online? Yes. No. Yes. Now next. Formation of chlorine. This is an example for yes. So formation of the chlorine is what is its endothermic reaction, means energy uses, or exothermic reaction means energy releases. Either exothermic or endothermic, or neither exothermic nor endothermic. Yes, we learned the formation of molecules. So energy uses. Yes. So what is confirmed? We say it is exothermic or endothermic reaction. So what is answer? Yes. So we confirm here. Okay, formation of chlorine required energy. They get come to close and form the Cl2 molecule. Yes. So this formation of Cl2 is the example for yes endothermic reaction. Now electrovalency of metal atom is maximum here. Yes. So here metal is there in every yes. Sodium is a metal, calcium is a metal, magnesium is metal, aluminium is metal. Now what about sodium hydride, NaH? Sodium hydride. So what is calcium carbide? CaC2, calcium carbide. Yes. What about magnesium oxide? MgO. Aluminium fluoride? AlF. Yes, AlF3. Yes. Now here electrovalency of metal atom is maximum. What is the electrovalency of sodium here? Sodium electrovalency here +1. What about calcium? +2. What about magnesium? +2. What about aluminium? +3. Yes. Now tell me what is the answer? So answer is aluminium trifluoride. So fourth one is answer. Yes. Now join now Telegram link Spark Academy online, and same numbers are given here as enroll your members, and results overview from our Spark Academy. Congratulations to all the students for the TS and Eamcet 2021 results they given see here. So how our graph is increased here 95%. So by year it is increased. See 2017, 2018, 2019, and whatever 2020, 21, 95%. Yes. So Spark Academy NEET 2021 results. So NEET results also in that we are in 97. So number of students MBBS, BDS, BA, HMS seats projected 550 and 19 states. So in the case of the NEET also we are in high position. Yes. Now some examples. So you have to solve. Post your answer in comments. See, cation is not isoelectronic with anion in. So what is cation? Charged particles are called ions. So here cation means positive charge, anion means here negative charge, which is not isoelectronic with anion. That one you have to find out. Next, solve and post your answer in comments. The second one, an element it belongs to second A group, alkaline earth metal group, and another element belongs to 6A group. This compound formed between A and B contains. So A and B contain what about their charges? Okay, A plus or B minus, A plus or B minus, A minus 2 or B plus 2, A plus or B minus 2. Yes, double charge indicating number 2. Clear? Yes. Next, the electronegativities of two elements are given 0.7 and 3.0. What is electronegativity? Non-metals, they have electronegative character. Here two non-metals, their electronegativity given 0.7, 3.0. The bond formed between them would be, what type of bond is there? Is it ionic, covalent, coordinate covalent, or metallic? So you have to find out, yes, what type of bond is there in it. Yes. So see today in this session we discussed what are the things we discussed in this session. In this session we discussed first one, what is chemical bond. Next, what is electrovalent theory? How the formation of the molecules takes place. What are the theories explaining here chemical bonding? Yes, theories which are explain the chemical bonding. And octet rule. So octet rule proposed and given by Lewis dot structures, that also we learned here. Next, how many types of bond? Which is primary bond, which is secondary bond. What are the examples for primary bond? What are the examples for secondary bond? And how ionic bond formation takes place. So what are the other names of the ionic bond? Electrovalent, polar bond. Now example for formation of the ionic bond, MgF2. Next, MgCl2. What is electrovalency? What is the electrovalency of sodium? What is the electrovalency of magnesium? What is the electrovalency of aluminium? What is the electrovalency of chlorine in NaCl? What is the electrovalency of chlorine in MgCl2? What is the electrovalency of chlorine in AlF? And what are the favorable conditions for cation? What are the favorable conditions for the anion? And related their example. This is how compound will form. First example. Second, what about variable valency property? Yes. Next, so how the X and Y here existed. So depends on their valency, means combining capacity. Next, formation of Cl2. What is the example? Exothermic or endothermic? And electrovalency, already exists some compounds there. In that, what is the metals? Electrovalency related question. So these things we are discussed in this topic as, and it is the starting introduction of the chemical bond. So what are the here as questions we are expecting? So what are the sessions that are also important from the chemical bond? So in that, as the Fossil's rule, hybridization, VS EPR theory, and Shapes bond parameters, molecular orbital theory, hydrogen bonding. Yes. So what are the sessions expecting we are here? So first, the Fossil's rule. Second, hybridization. Pick out the hybridization of the atom in a molecule, central atom. Shapes, bond parameters, and molecular orbital theory. Yes. So hydrogen bonding. These are we are expecting sessions. Okay, from this chemical bonding. Yes. And at the last we given how many questions to you? We given the 3 important questions for you at the last. That questions you have to solve and post with your comments. Okay, thank you students.